All right, so we're going to go ahead and go through problems 9 through 12 on the Trig Identities worksheet. So this one's a pretty challenging one, a pretty tricky one. Um, yeah, we're just going to go ahead and dive into it. There are many different ways to go about it, but I'm just going to go ahead and do it the way that I see this one. So to me, the left-hand side seems to be the more complicated one. There's more trig functions, more going on in this fraction, so we're going to try to simplify this one as much as we can. The first step that I'm going to take is to write everything in terms of sine and cosine. So I end up with sine theta minus 1 over sine theta divided by cosine theta minus cosine theta divided by sine. Something that we can notice here at this stage is that both of the denominators that we have, so our fractions inside of here are sine. So I can actually cancel this out by multiplying both of my numerator and denominator by sine theta. And I'm allowed to do that. I'm allowed to multiply the numerator and denominator by the same thing. And that's going to get rid of these. That's going to cancel those out when I do this multiplication. So sine times sine ends up being sine squared. Sine times this one, remember, cancels out, right? Cancels out with this one. So we just get minus 1. And then here we have sine times cosine, which is just going to have to be sine times cosine minus, and then again, when we do this multiplication, the sine cancels out, so we just get cosine. Okay, this sort of looks better, maybe. Depends on if you squint at it or not. We're trying to get to this. Maybe we're closer, maybe not. I do notice in the denominator here, I can factor this. They have a cosine in common, so I could factor that out. And I do notice here I have difference of squares that could be factored as well. Let's just see what happens when we factor both of these. So difference of squares, I have sine squared minus 1 squared. So that's going to factor as sine minus 1 times sine plus 1. I went ahead and stopped writing my variable here just to sort of save some writing. And then when I factor out this cosine, right, I have a cosine, take that away from both terms, right, factoring it out, I'm left with sine minus, and when I factor away a cosine here, just left with 1. And here's where we're getting somewhere. We're starting to get there. Two of these factors cancel. Nice. Wasn't super obvious, but they did cancel. So now I'm going to go ahead and write this up here, what we're left with. Sine plus 1 over cosine. We're not quite there yet, but we're kind of closer. Kind of looks similar. This is a situation where I could kind of mess around with this, see what's going on with it. I could maybe try like dividing this through, see what goes on. But my best bet, at least in terms of when I was looking at it, was to take a break from the left-hand side and do something to the right-hand side. Okay. And sometimes this is useful. Sometimes it's okay. You're like, I can't quite get here. Feel like I'm close, but I can't quite get here. This is the time where you need to take a look at this and see what you can do here. And I think we can do that. Whenever you have something in the denominator like this, 1 minus sine theta, 1 plus cosine theta, something you could think about doing, you could consider doing is multiplying by its conjugate. So we're going to do that. We're going to multiply by 1 minus sine theta. Sorry, 1 plus sine theta. The conjugate of that would be plus. So again, I'm working completely with the right side now. So I'm multiplying by 1 plus sine theta on the right-hand side. Okay, let's see what happens with that. I'm going to leave it factored on the numerator. I know that I usually say to not do that, but I'm going to do it. So I end up with cosine theta times 1 plus sine theta divided by, these are conjugates, so they're going to multiply to be 1 minus sine squared. Well, this is actually a Pythagorean identity. this is actually just equal to cosine squared. So let's do that. We have cosine times 1 plus sine all over cosine squared. Well, we have some things that can cancel here. I have this cosine can cancel with one of those, so it'll no longer be squared. So now I end up with 1 plus sine divided by cosine. Ah, these look more alike. In fact, they're almost exactly alike. The only thing that's different here is we just reordered this addition, which is totally fine. We can do that simple commutative property. So sine plus 1 over cosine. There's probably a better way to do this, something that I missed from this stage to get us to that. But oftentimes, you get to a point with one side where you just can't really go any further, where you don't see it. And you at that stage, you can break some of the rules we had. They were only guidelines. You don't have to exclusively work with one side. It's just that would be the preference. So in this case, we ended up working with both sides and showing that they sort of meet in the middle to be equivalent to one another. All right, let's go ahead and clear that. That is probably the hardest one we've done so far. All right, so here is another one we got. These last few are pretty challenging. So in this case, left-hand side's way more complicated. A lot more going on here. So what we're going to do is we're going to get a common denominator. And these denominators are actually conjugates. So when we start multiplying things out, it's gonna really, I think, really start to make sense. So let's, for this first one, cosine x over 1 minus sine x. I'm going to multiply this one by the 1 plus sine x. So we're multiplying this by 1 plus sine x on top and bottom. Okay. And then on the other one, we're going to do a very similar thing, right? We have cosine x over 1 plus sine x. We're going to multiply by 1 minus sine x. And, we ended up just sort of multiplying by conjugates here, which is fairly convenient actually. And to make this work even a little nicer, I am going to leave the tops unmultiplied. I'm going to leave it factored for a minute here, and I think it will make sense in a moment why. So we end up with 1 plus sine x over cosine x divided by 1 minus sine squared x. This is a Pythagorean identity. This is simply equal to cosine squared. Notice now I have a cosine on top, cosine squared on the bottom. Some things are going to cancel here. This cosine will cancel. This squared will cancel, and I'll just have cosine in the denominator. Very similar thing's going to happen on the right-hand side one. Again, I'm going to leave that unmultiplied, so it's cosine x times 1 minus sine x. And we get the same denominator. We're multiplying these conjugates together. We end up with 1 minus sine squared x, which again is a Pythagorean identity, a well-known one. This is actually equal to cosine squared. We have a cosine on top, which cancels with this one of these cosines here, so it's no longer squared. Okay, let's rewrite this, make this look a little bit cleaner. We have 1 plus sine x over cosine plus 1 minus sine x over cosine. Add these together. 1 plus 1 is 2. Sine x plus negative sine x. Those go away. We end up with 2 over cosine x. Got to keep in mind where we're trying to get to. We're trying to get to 2 secant. Well, we're basically there. This is the same thing as 2 times 1 over cosine x, which is the same thing as 2 times secant. Secant x. So there we go. We got there. Kind of a tricky one. Anytime we have these big fractions here like this, and we got to try to put them together, got to get a common denominator, see what cancels out. There we go. Actually not quite as difficult, I think. Looks more intimidating than the last one, but actually was a little bit easier than number 9, I think. All right, let's go ahead and move to the next slide. Ooh, here we go. And this one looks even more intimidating, but I think is even easier than both of those two, especially with this hint. So we have tangent x plus cotangent x raised to the fourth power is equal to cosecant x to the fourth times secant x to the fourth. Hint, simplify tan x plus cotan x as much as possible by adding fractions and then do the exponent. So they want us to combine this together, then use the exponent. So let's actually do that. Let's just add tangent x plus cotangent x. So tangent is sine over cosine plus cotangent is cosine over sine. I'm just going to kind of show this work off to the side here. We need to get a common denominator, so I'm going to be multiplying this one by sine over sine and this one by cosine over cosine. So we end up with sine squared over sine cosine plus cosine squared over sine cosine. Put this together into one thing. We got sine squared plus cosine squared, well-known Pythagorean identity. This equals 1 over sine times cosine. So we end up with 1 over sine x times cosine x. So that's what we get when we put those together. So really what we're looking at here, these things, right? We're just showing some work here of what tangent x plus cotangent x is. We end up with 1 over sine x times cosine x to the fourth. Well, we raise this to the fourth. That means we're just multiplying this by itself 4 times. So that's 1 over sine cosine times 1 over sine cosine times 1 over sine cosine. You get the point here, right? I'm going to write it out, but we could just use exponent rules here. We end up sine times sine times sine times sine. We end up sine to the fourth in the denominator, x times cosine to the fourth, x. All that's, ones on top. And we can go ahead and split that up. Why not? That's 1 over sine to the fourth times 1 over cosine to the fourth, which is basically where we're trying to get to. This is equal to cosecant to the fourth times secant to the fourth. Couple ways we can do that at the end. We don't necessarily have to expand it out like here. Since everything is multiplied here, you can just distribute this exponent to all parts, right? 1 to the fourth is 1, sine to the fourth, cosine to the fourth. So, as long as there was no pluses or minuses, we can just kind of do it this way instead of expanding it, but it works that way too. All right, that hint was clutch. Last one. Okay. Looking at it, could probably go about this either way. Could probably try to work on the left side and put those together and see if it ends up matching this. Or we could do something with this side and not really sure. Let's, your choice. Actually, we may end up doing both. I think the way to do this side is to actually multiply by a conjugate. So to get this into something else. So let's do that. We're going to multiply by 1 plus sine on the top and the bottom. Okay, so we end up with 1 plus sine theta times cosine theta over 1 minus sine squared, which we've seen before. Well-known Pythagorean identity for us at this point. This is just equal to cosine squared, which also is going to simplify, right? This cosine will cancel out, and one of these will go away. So we end up with 1 plus sine theta divided by cosine theta. All right, and to top this off, we're pretty close to the answer. We can just distribute this division to both of these. So that becomes 1 over cosine, right, dividing it there, plus sine over cosine. That's secant plus tangent. Straight up the easiest one we've done, I think, as long as you notice this nice conjugate idea. Let's see what happens if we try it from the other side. Let's see what happens if we try it from the left-hand side. So let's rewrite this. This becomes 1 over cosine plus sine over cosine. Okay. That's just going to become 1 plus sine over cosine. Ooh, and we kind of get that situation we had on number like 9 or 10. I don't remember which one it was, but they look so different, but like close, and man, it just feels like it should work out. It's probably a matter of conjugates again, but I'm not convinced. What happens if we do conjugates? Let's do that conjugates idea again. So let's multiply by 1 minus sine times 1 minus sine. That's going to give us 1 minus sine squared, which is cosine squared, over cosine times 1 minus sine. This gives us the 1 minus sine in the denominator we're looking for. And yeah, I think I can see it now. So we already said this simply equals cosine squared. So now we have a cosine on the bottom that cancels with one of these. So now we have cosine on top, which is what we wanted, and only 1 minus sine left on the bottom, which again is what we wanted. Okay. I think I could have done number 9 this way too, so, you know, that's okay. Sometimes you see it later, but yeah, it works from both sides. I think the easier way was the first way we did it. And I think this looks more complicated, but you may disagree, so you may have worked with this side, but they both work. All right, guys, hopefully that was helpful, and see you guys in class.